What if some of the tallest towers on Earth were built before modern mathematics even existed? No advanced calculations, no computer simulations, no structural software, and yet they stand perfectly balanced, perfectly aligned, still standing after centuries, because across the world there are towers that rise into the sky, built in a time when the formulas we rely on today didn't exist. Before we go deeper, stay with the journey and subscribe, because what you're about to uncover may completely change how you see ancient intelligence. Because this isn't just about height. This is about precision, without equations. Let's begin in Italy with one of the most famous towers ever built, the Leaning Tower of Pisa. At first glance, it looks like a mistake. A tower that leans, a structure that should have collapsed long ago, but it didn't. Instead, it survived for over 800 years. Now think about that. A tower built on unstable ground, with a visible tilt, and yet it still stands. Because over time, builders made adjustments, subtle corrections, balancing the structure as it rose. Without modern calculations, without precise measurement systems, just observation, experience, and understanding. Now move to India, where the towering Qutub Minar rises into the sky, over 70 meters tall, built in the 12th century, layer upon layer of stone, intricate carvings, perfect symmetry, no steel reinforcement, no modern foundation systems, and yet it has stood through earthquakes, storms, and time. Now ask yourself, how do you build something this tall? Without modern math? Because when you build upward, everything changes. Weight increases, pressure builds, stability becomes critical. One small miscalculation, and the entire structure fails. And yet, these towers didn't fail. They worked. Now think about the pattern. Different regions, different cultures, different materials, but the same result. Height, stability, longevity. Because ancient builders didn't just guess. They understood something deeper. Balance, proportion, geometry, not written as formulas, but learned through practice, passed down through generations, refined over time. Because sometimes knowledge doesn't come from equations. It comes from experience. And that leads to the first big question. If ancient builders could achieve this level of precision, what methods are they using? Because in the next part, we go deeper into towers built in extreme conditions, structures placed where stability itself should have been impossible. Stay with the story, because what ancient builders achieved might be far more advanced than we think. What if building a tall tower wasn't the hardest part, but where it was built? Because across the world, there are towers standing in places where stability itself should be impossible. Soft soil, unstable ground, harsh environments. And yet, they rise. Before we go further, stay with the journey and subscribe, because what you're about to see may completely change how you define engineering. Because now, we are not just talking about height. We are talking about location. Let's begin in Italy again, with the Leaning Tower of Pisa. This tower wasn't meant to lean. It started tilting during construction. The ground beneath it, soft and unstable, couldn't support the weight. By all logic, it should have collapsed. But it didn't. Instead, the builders did something extraordinary. They adapted. Each new level was slightly adjusted. Angles were corrected. Weight was redistributed. Not perfectly, but just enough to keep the structure standing. Now pause and think. A mistake turned into stability. Without modern calculations. Without structural modeling. Just observation and correction. Now move to Yemen, to a city that looks like something from another world. Shabam. Hey, towers rise up to 11 stories high, but they are not made of steel, not concrete. They are made of mud brick. Yes, mud, stacked, lead, rising vertically in a desert environment, and still standing for centuries. Now ask yourself, how do you build vertical structures out of mud and make them last? Because mud is fragile. It cracks, it erodes, it weakens over time, and yet these towers survive. Why? Because the builders understood their environment. They designed thick walls at the base, gradually reducing weight as the tower rises. They maintained the structures regularly, reinforced them with natural materials, created a system that worked with the environment, not against it. Now think about the pattern. A leaning tower that survives on stable ground. A city of mud towers that defies material limitations. Different challenges, different solutions, same outcome. Stability. Because ancient builders didn't rely on perfect conditions. They adapted to imperfect ones. They observed. They adjusted. They learned from what worked and what didn't. And that's what makes these towers so powerful. Because they prove something important. Engineering is not just about formulas. It's about understanding reality. And ancient builders understood it deeply. Which leads to the next question. If they could build towers in unstable and extreme conditions, what about structures that seem almost too precise to be real? Because in the next part, we explore towers with perfect symmetry and alignment, designed so exact they challenge everything we think about ancient construction. Stay with the story, because what you're about to see doesn't just challenge history, it challenges logic. What if the real secret behind these towers wasn't mathematics, but method? Because designing a tower is one thing, but building it perfectly aligned, perfectly balanced, without modern tools, is something entirely different. Before we go further, stay with the journey and subscribe, because what you're about to uncover may completely change how you see ancient construction. Because now, we go behind the scenes, into the techniques, the systems, the forgotten skills. Let's begin again in India, where the Qutub Minar rises with incredible precision. Each level stacked perfectly, each section aligned vertically. But here's the question. How did they keep it straight? Without laser tools, without digital measurement. The answer lies in something simple, but powerful. Plumb lines, a weight tied to a string, used to find a perfect vertical line. Gravity itself became the guide. Now think about that. Instead of advanced instruments, they used nature. Now move to Italy, where builders of towers like the Leaning Tower of Pisa use water levels. A basic concept. Water always finds its level. By observing water surfaces, they could ensure horizontal alignment. Simple, effective, accurate. Now consider something even more important. Ramps, wooden scaffolding, layer by layer construction. Instead of lifting massive materials straight up, they gradually raised the working level, building upward as they progressed, turning vertical construction into a series of horizontal steps. Now imagine coordinating this process. Workers cutting stone, others transporting materials, others aligning each block, without radios, without machines, just coordination, experience, and trust in the method. Now think about measurement. Without rulers as we know them today, without standardized units. So how did they maintain consistency? They used repetition, templates, ratios, a single measurement repeated across the structure. Because consistency doesn't require advanced tools. It requires a reliable system. Now consider something even more fascinating. Ancient builders often tested their structures as they built them. If something shifted, they corrected it. If something cracked, they reinforced it. A continuous feedback process. Not perfect, but adaptive. Now think about the pattern. Plumb line for vertical accuracy. Water level for horizontal balance. Ramps for lifting. Repetition for consistency, observation for correction, simple tools, powerful results. Because when you combine these methods, you get precision, not by calculation, but by process. And that's what makes these towers so extraordinary, because they prove something important. You don't always need advanced technology to achieve advanced results. You need understanding, which leads to the final question. If ancient builders had such effective systems, why do we assume they lack knowledge? Because in the final part, everything connects, and we uncover what these towers truly reveal about human intelligence and capability. Stay with the story, because what ancient builders achieved was never simple. It was genius. What if the tools used to build these towers were too simple to explain the results? No machines, no digital precision, no advanced mathematics. And yet, the outcome was perfection. Before we go further, stay with the journey and subscribe, because what you're about to uncover may completely change how you see ancient intelligence. Because now, we are stepping into the hidden process, the part history rarely explains, Let's begin with something incredibly basic: gravity. In places like India, builders of the Qutub Minar didn't need advanced instruments to find a straight line. They used plumb lines, a simple string with a weight, hanging freely, always pointing straight down. Perfect vertical alignment, every time. Now think about that. The Earth itself was a measuring tool. Now move to Italy, where structures like the Leaning Tower of Pisa reveal another method. Water, still, flat, unchanging, used to create perfectly level surfaces. No sensors, no calibration, just observation. Because water never lies. Now consider the real challenge. Height, lifting heavy stone blocks, without cranes. So what did they do? They didn't fight gravity. They worked around it. Ramps, gradual elevation, step-by-step construction, turning a vertical problem into a horizontal solution. Now pause. This is not just building. This is strategy. Now imagine the coordination. Dozens, sometimes hundreds of workers, each with a role, each step dependent on the last. No instant communication, no second chances, because one mistake at the base means failure at the top. And yet, they succeeded. Now think about measurement. No standardized rulers, no digital units. So how did they maintain proportion? Repetition, ratios, templates, one unit, cup it again and again, creating symmetry, creating balance, creating stability, because precision doesn't always come from complexity. Sometimes it comes from consistency. Now consider something even deeper. They didn't just build once and hope it worked. They observed, adjusted, improved. If something shifted, they corrected it. If something weakened, they reinforced it. A continuous process, alive, adaptive. Now look at the pattern. Plumb line for vertical accuracy, water for horizontal balance, ramps for lifting, repetition for precision, observation for correction. Simple tools, extraordinary results. Because when methods are strong, tools don't need to be. And that's what changes everything. Because it proves something powerful. Ancient builders were not limited. They were efficient. They understood how to use what they had to achieve what seemed impossible. Which leads to the final question. If simple tools could create such advanced structures, what does that say about human potential? Because in the final part, everything connects, and we uncover the real truth behind these towers. Stay with the story, because what you're about to realize is bigger than history. What if these towers are not just structures, but proof of something we've misunderstood? Because when you connect everything, the height, the precision, the extreme locations, and the simple tools, you begin to see a pattern that is impossible to ignore. This wasn't primitive. This wasn't accidental. This was intelligent. Before we reveal the final truth, stay with the journey and subscribe, because what you're about to realize may completely change how you see human capability. Because now, everything connects. In Italy, the Leaning Tower of Pisa still stands, despite its tilt. In India, the Qutub Minar rises with perfect proportion. In Yemen, the towers of Shabam reach incredible heights using only mud brick. Different cultures, different materials, different environments, but the same outcome: stability, longevity, precision. And that leads to the final realization. Ancient builders didn't lack mathematics. They used it differently, not written in equations, not calculated on paper, but understood through practice, through observation, through experience. Because mathematics is not just numbers. It is patterns, balance, proportion, and these builders mastered it. Now think about the difference. Modern engineering relies on complex formulas, advanced simulations, powerful machines. Ancient engineering relied on something else: understanding, patience, adaptation. They didn't force structures into existence. They worked with materials, with gravity, with the environment. And that's why these towers still stand today, because they were built to last, not just a function. Now consider something even more powerful. These structures were not built once and forgotten. They were maintained, adjusted, improved over time. A continuous relationship between humans and their creations. Because building wasn't just a task. It was a system, a tradition, a form of knowledge passed down through generations. And somewhere along the way, we began to rely more on tools and less on understanding. Now ask yourself, have we advanced, or have we simply changed the way we build? Because when structures built centuries ago still stand, it forces us to question what we truly know, which leads to the most powerful thought of all. Human potential has always been there. The tools may change, the methods may evolve, but the ability to create something extraordinary has never depended on technology alone. So the next time you look at a tower, remember this. You're not just looking at stone or brick. You're looking at intelligence, at knowledge, at a level of understanding that still challenges us today. If you want more hidden engineering secrets, ancient knowledge, and untold history, make sure you subscribe and stay with us. Because the deeper you look, the more you realize we've only just begun to understand what came before us.